Okay, so now I want to talk a little bit about the vasculature of your brain because in order to function properly, you have to deliver blood to all the different regions of the brain that are going to be involved in all these different cognitive abilities and all the basic sort of kind of housekeeping, breathing, respiration, modulatory transmitter release, all that of the brainstem and other structures we've been discussing, right? Well, when you feed your brain that you're talking about, delivery of blood through the vasculature, through the blood system, through the plumbing, right? And so what you have, of course, are a lot of vessels, and some that you should know, right? So, for example, let me show you what I'm looking at here. If you feel in your neck, first of all, what you're feeling actually right there is a bump, bump, bump. This is called the common carotid artery. There's one on the left and there's one on the right. Okay, and this common carotid artery is going to branch, and it'll form on one side. It'll be and the exterior. There's going to be two. There's one on the left and one on the right. The external carotid is going to feed the face and the head, right? Basically with blood, and the internal carotid is actually going to go and feed various portions of the brain, specifically the anterior circulation of the brain. The circulation of the brain in the forward portions of the brain, right? And let's take a look at this a little bit. So the internal carotid artery, what this is showing you is we've cut the internal carotid artery here and here. And the way to get a good sense of what I'm describing here is to actually look at it on a brain, right? So let's see if we can do this up close. So here we're looking at the ventral surface, right, of the brain, and right here we'll see this a little bit later. These white kind of things here actually are what we call your optic tracts. Right? These are coming actually from your eyeballs. But right there, do you see that blood vessel that's been cut, and that blood vessel that's been cut? Well, this is basically what we're examining right here, right? You see where it's been cut in those locations? And I want you to see those branches that go off here and go off on the other side over there, right? Let me take this down here and show you. So now we're looking at, this is sort of anterior, right, towards the front. Here we've got what's called the middle cerebral artery, which is going to go off through the sylvian or lateral fissure. So here we've got what we're talking about. Here are those, the internal carotids right there have been cut there and there. Now I'm going to remove, with that, let's see, I'm going to take the cerebellum off because it always drops, okay? Now I'm going to take over this portion, take off this part here. And you can see this middle cerebral artery continues through that sylvian or lateral fissure, right? And it feeds the insula, and it'll feed, it turns out, vast areas of the lateral surface of the cortex. So these are like branches of the middle cerebral artery emerging, right, out of the sylvian or lateral fissure here, right? And they're feeding vast areas of the lateral surface of the cortex. So a lot of cortex that's important. We'll see for language function, for example. On the right hemisphere, we'll see for selective attention. All sorts of important cognitive abilities. Those regions are actually fed by blood that's coming out of the middle cerebral artery. Okay, now let's look a little bit again as I make this brain fall apart. Here's our, again, our internal carotids here have been cut. Here are the middle cerebral that go off through the various, the two lateral fissures, right, and feed the lateral surface of the cortex. And then you've got these branches off of that internal carotid artery that are going forward, under the ventral surface of the, the temporal lobe, but then basically coming through that longitudinal fissure. Okay, let's take a look up here again at this. So they're going to be coming, through the middle here, right, and coming out and feeding parts of the ventral frontal lobe, and also, around the sort of distal edges here of the frontal lobe, basically the anterior portion of the cerebrum. So remember, the middle cerebral is going to get a lot of the frontal lobe over here, but little branches of the anterior cerebral artery are going to come around and feed these most anterior and dorsal portions of the frontal lobe as well. So you can get some, significant loss of frontal lobe regions, right, in the anterior, sort of dorsal portions, right around the longitudinal fissure, right, with occlusion or blockage of the anterior cerebral artery. Okay, now, so basically the anterior cerebral artery and the middle cerebral artery are coming off of the the internal carotid artery, right? Now, there's another vessel that you need to know that's going to be providing, a lot of the posterior circulation of your brain, and this is the one that's shown right here on this diagram. This is what's called the basilar artery. You'll note it's a single artery right here. Usually things are paired, right? It's actually formed from the merger of these two arteries here that are called the vertebral arteries, and they're called vertebral because they're going to run down your spinal cord, right? The vertebrae on the left and the right, but they merge together right here on the ventral surface, right, of the brainstem. So here are two vertebral ones, right? They're going to be running down the spinal cord, and here they've merged into the basilar artery, right? And then they're going to join up here, right? They're actually going to, branch off these what are called posterior cerebral arteries. These guys coming off here, right? These are the posterior cerebral arteries, and these are going to feed, areas of the occipital lobe, so occipital cortex, the more caudal regions and ventral regions, basically, at the posterior portion of your brain, okay? Now, one other feature of the vascular system I want you to sort of recognize here is you've got, your middle cerebral, these great big middle cerebral, and you've got these anterior cerebral, and you've got these posterior cerebral, right? Well, look at this. They're linked together. They're connected, right? Even the two little anterior cerebral ones are connected, right? These connecting arteries are referred to as communicating arteries, and they form, very distinctive kind of circle here at the ventral surface, right? And this circle is important clinically. It's called the circle of Willis, and it turns out that not everybody has a complete circle of Willis. And some people, like the communicating arteries, just sort of peter out or don't quite reach, right? Well, if you don't have a complete circle of Willis, you're actually in more danger of having significant damage from a stroke, right? Because if you, somehow occlude, one part of the circle, the blood can actually flow around the other way, actually to reach, the various cerebral arteries to go, feed various regions of your cortex. But if you have an incomplete cerebral circle of Willis, you're in greater danger of actually having an occlusion, prevent blood flow out one of those arteries and, starving, brain tissue of blood.